Good morning, everyone. Okay, last lecture we have solved a numerical on simply supported beam. Today also we have taken one example of the simply supported beam. Okay, let's see how to solve this given numerical. First, what is the given? You have given the simply supported beam. Okay, the support is given at point A and at point B. Okay. So we have given the point load 10 kilonewton at C point and 7 kilonewton at D point. Okay, and total distance is given 8 meter from A to B. A to B. Okay, then how to solve this given numerical? Okay, in that numerical we want to draw SF diagram as well as BF diagram. Okay, also when you calculate or when you draw the bending moment diagram, we want to calculate the maximum bending moment. Maximum bending moment. Then how to solve this type of numerical? We will see the details. Okay, you know what is the first step? We want to calculate the support reaction. Okay, so right here, first step is a support reaction. Support reaction. Calculate the support. You know the sign conventions for the equilibrium. Okay, and consider the upward direction in a positive direction. You can take the section here. Okay, this after the load. After the load, you can consider this side also, but we will consider after the load. Okay, then see first is a upward direction is I will consider the positive. Then summation of Fy means is equal to 0. All vertical forces is equal to 0. Okay. Then you will get, see the vertical, which is the vertical forces or upward direction forces. Here is the A is there. Support is there. We will consider the RA is the reaction at support A and RB is the reaction at support B. Then you will get the two support. First is a RA plus RB because of upward direction. Upward direction. Then check that is there any force act in the downward direction? There are two forces at the point C and D. 10 kilonewton and 7 kilonewton. Means this will get minus 7, 10 minus again minus 7. Then again there is a one UDL is that in between C to D. C to D. Okay. This force you have to convert into the again point load. Okay. How to convert force into distance? Okay. Check that. This how much load is at 2 and how much distance 4.5. 2 into 4.5. And this will act again in downward direction is equal to 0. Is equal to 0. Okay, then you will get take that the relation RA plus RB is equal to minus 10 minus 7 and this 2 into 4.5 minus 9 is there is equal to 0. Then you will get the first relation RA plus RB is equal to what? 26. 26. This is the first relation. Okay, with the help of support reaction you can calculate the reaction at point A support and reaction at point B support. Once you have got the RA plus RB relation, then we want to find out any one. Okay, then again second one, we want to take the summation of movement at point A is equal to 0. Okay, I have considered that point and summation of all bending movement at that point is equal to 0. Is equal to 0. Then see, I will consider again here sign convention. Clockwise is positive. Clockwise is positive. For equilibrium, then again you will get the anti-clockwise. Okay. See, check that at point A means we are coming from right to left. Right to left. This force, check that C is going in which direction? We have considered here section. Right. This is going clockwise direction. That's why positive. 10 into distance. What is the movement? Force into distance. 10 into distance up to the A point. How much distance is given? 2.5 meter. 2.5 meter. Okay. Then next one. Next, is there any force is that? Then I will consider this force. This force 7 kilonewton. Okay. We will consider first point load. Then again, these are going clockwise direction. 7 into what? 7 into distance up to the A to D distance. Okay, 2.5 plus 4.5 means 7 is there. Right? 7 is there. 6 and 7. Yes. Is there any force again acting in between C and D? There is a UDL is given. And how to convert again that UDL? Plus. Check that. If you have convert this UDL into point load, then 2 into 4.5, you will get 2 into, I will write here, 2 into 4.5. And where is that? At the center. At the center. Means what? Where is that? This 4.5 divided by 2 is there. Half distance. From C to D, we will get the half distance. How to get? 4.5 divided by 2 is there. Okay, and plus what? Remaining distance up to the A. We are coming from the center to the A point. Center to the A point means half distance of that C to D. You will get 4.5 divided by 2 plus 2.5 plus 2.5. Okay, check that. Then check that again. RB is going anti-clockwise direction. RB is going anti-clockwise direction. Okay, that's why minus RB into total distance. We are traveling B to A. Its total distance is 8 is equal to 0. If you have calculated this, then you will get the RB is equal to you will get 14.6 kilonewton. 14.6 kilonewton. Okay. We have calculated this, all the calculations, then you will get the RB is equal to 14.6 kilonewton. Put this value in this equation. Okay, this equation, you will get RA is equal to what? RA is equal to this 14.6. Okay, we will shift that side. 26 minus 14.6. You will get the 11.4. 11.4 kilonewton. Okay, 11.4 kilonewton. Okay, this is the support reaction. All of you getting how to calculate the support reaction? Once you have calculated the support reaction, then we will draw the step diagram. Check that. RA is equal to what? 14.6 is there. And what is the 11.4 is there. And what is the RB? RB is equal to 14.6 is there. Okay, then you have to write the calculation for SF, or you can directly draw the SF diagram, and after that you can write the calculations. Okay, for the SF. Check that SF at a point. I will draw directly here the SF diagram. Check that how to draw. We'll draw first 0 line. Okay, mark the point on that 0 line. A is there, then second C is there, then D is there, and B is there. Okay, about the A point we have the 0 line at the 0. Okay, we'll start from the A. Okay, see we have the 11.4 kilonewton. This one positive force. They are going upward direction. Okay, we are getting the positive value for that. Then we will travel from that 0 to 11.4. 11.4. You have to mark the approximate distance. Okay, in the examination also you have to take the approximate distance. This one 11.4 kilonewton. Then check that A to C there is no load. A to C there is no load. Then we will travel the horizontally. Okay, means same load is there. Up to that point A to C 11.4 kilonewton. Okay, then check that how much load is at the C point. In which direction? Downward direction. Downward means negative. Negative force is at 10 kilonewton. We have the positive 11.4 kilonewton and this minus 10 kilonewton. Minus 10 kilonewton. Then how much we will get? Positive 1.4 kilonewton. Let's see here, suppose 1.4 kilonewton. Yes, all of you getting? See how to draw this without calculation. You have to do here calculation only. We have the 11.4 kilonewton positive load, then minus this 10 kilonewton, we will get the 1.4 kilonewton positive load. Okay, on the same point, C point. Then after that, check that in between that C and D, there is a UDL is there. What is the value of that UDL? 2 into 4.5. 2 into 4.5. Okay, we have the 1.4 kilonewton positive. Then 2 into 4.5 we will get the 9. Okay, we will get the 9 kilonewton. Right? Means this acts in downward direction again. This acts downward direction again. This minus 9 means we have the positive 1.4 and minus 9. Okay, how much you will get? You will get at the point D. Check that. I will check that how much you will get. This value. Yes, you will get 11.4. Check that. 1.4 minus 9 is there. No? You will get the minus 9 plus 1.4. You will get the 7.6. Minus 7.6. We are coming downward direction. Downward from the 0 line. 7.6 kilonewton. Means here, if UDL is that, then you have to draw inclined line. Okay. This type of shear force diagram you will get. Then after that, check that D to B, there is no force. That's why we will travel straight line. Then, sorry, here is one more load is at the downward direction 7 kilonewton. On which point? D point. Means already we have the 7.6 kilonewton minus 7 kilonewton. Means we will get the 14.6. Yes, we are coming on the same point. We will get the 14.6 kilonewton. There is no load in between D to B. We will travel the straight line. Again, you will get the same load. Guys, check that. You will get the same load at the B point, at the left side and right side also. Check that RB is equal to, we have checked that RB is equal to, already we have calculated 14.6 kilonewton. 14.6 kilonewton means RB is equal to 14.6 positive and RB is equal to what? Minus 14.6. That traveling upward direction, you will get the 0. And this is the negative, this is the positive. Very simple. Then after that you can write the calculation for the SF. Check that. I will write SF at A point just left side is equal to 0. First and last point is 0. We are start from this point. Okay, that's why you will get the 0. Then SF at same point at the right side. Check that how much value we will get. 11.4 kilonewton. 11.4 kilonewton. Then SF at next point, which is the next point, C is there. Okay, SF at C point, just left side. Just left side. What is the value of that point? Check that. At the C, we will get the 2 point, again 11.4 kilonewton. Okay, then SF at C point, just right side. How much value we will get? 1.4 kilonewton. Means this 11.4 minus 10, you will get the 1.4 kilonewton positive. Okay. Then SF at D point just left side. Check that. SF at D point just left side. Here also we will get the 2 points. Check that. 7.6 minus 7.6 kilonewton. How to get this? How to get this? This 1.4 positive 1.4 minus. Again you will get this 2 into 4.5 minus. Okay, means plus 1.4 minus 9, you will get the minus 7.6. And SF at D, just right side, you will get how much value? Again 14.6 minus 14.6 kilonewton. Because minus 7.6 we have, and there is one more load is at 7 kilonewton. You will get the 14.6. Then SF at next point, B point, just left side, is equal to, again you will get the same value because there is no any load in between C to B, D to B. Then SF at B, just right side, you will get the 0. Guys, remember that once you have drawn the SF, then easily you can do the calculation. How to do, I will tell you. See, first we will travel from the A point. You have to consider the left side. Then here is the right side. Okay, you will get the 2 points. First point is the left, second point is the right. Check that. SF at A, left side point 0. SF at A, then right side 11.4. Same value you will get. Then we are traveling in this way horizontally. Then here is the left and right point for the C. You will get the same value. For the D, then we are traveling inclined left and right. Again left and right. Okay, in this way you have to write the calculations directly. Okay. Once you have drawn, do the calculations. Then after that we want to find out the bending moment at each point. Okay. Then BM calculations. Okay. See again, first and last point you will get the same. Bending moment at A point, you will get the 0. Then bending moment at next point which is the next point, C is equal to. Okay. Guys, remember that we have traveled left to right. When you calculate the bending moment calculation, then we will travel left to right. Means A to C. See, is there any force? Yes, there is the upward direction force. This will going clockwise direction. That's why we will consider 11.4 into what is the distance? 2.5 meter up to the C. Okay, 2.5 meter. Then you will get 11.4 into 2.5. You will get the 28.5 kilonewton meter. What is the unit? Kilonewton meter is there. Okay, 28.5 kilonewton meter. Then bending moment at D point. Next is the D point. We will travel A to D. Then take that 11.4 as it is on the A. This is going clockwise positive up to the distance D. How much distance is given? 2.5 plus 4.5. Then 7 is there. Then is there any load is that in between A to D? Yes. Point load and UDL is that. This is going anti-clockwise direction. C to D. Okay, C to D. This is going anti-clockwise direction. Minus 10 into 4.5 is there. Okay, 4.5 is there. One more load is that in between C to D. How much load is that? This one minus 2 into what? 4.5 load is that. Because again this load is going anti-clockwise direction from C to D direction. Okay, 2 into 4.5. Okay, where is that this 4.5 divided by 2. Okay, means at the CG of that C and D, 4.5 divided by 2. Okay, then how much distance is remaining? Check that. We are traveling for which direction? Plus 4.5 divided by 2 plus what? Half distance of that. Again 4.5 divided by half distance of that 4.5 divided by 1 minute. 4. Minus 10 into 4.5 minus 2 into 4.5 divided by 2 is there. Yes, this is the half distance of that. Check the value. Okay, we have this value 14.6 kilonewton meter. This is the bending moment at D. If you have calculated the bending moment at B, then definitely you will get the 0. Last lecture we have seen already. This is the bending moment calculations. But see, when you draw the bending moment, each and every point you will get this. We want to calculate the, again I will draw first BMD diagram. See, A point, C point, D point, then B point is there. What is the value of A point? 0 is there. What is the value of B point? 0 is there. What is the value of C and D point? Check that. C is 28.5 is there. 28.5 is there and D is 14.6 is there. Okay. A to C will get the 28.5. But how to draw this? How to draw this? You have to draw, if there is a horizontal line, then you should draw here inclined line. Incline. This value, suppose we will get here 28.5 kilonewton meter is there. And next one at the B point. At the B point, check that this value is a 14.6 is there. Again here is a horizontal line. That's why we draw the inclined line, because as compared to this value is less. That's why draw proportionally. Okay, kilonewton meter. But here is a inclined line. When you will get the inclined line in SSB, then you should draw the parabolic curve. You should draw the parabolic curve. Then how to draw this parabolic curve? Here we get 0 shear force. 0 shear force. Okay, means we get the maximum bending moment at that point. We want to find out that bending moment. Okay, then how to calculate that bending moment? See, if you are getting here triangle, see that the C point to the D point, we'll consider only this C to D, C to D. Here we'll get the one triangle and here we'll get the another triangle. You have seen in the mathematics subject, or you have used mathematics subject how to find out the distance. Okay, we'll consider this distance. Check that. We don't know where is the this will get the shear force is 0. We know this distance 2.5 only. Okay, we will consider this distance A. Okay, what is the remaining distance? What is the remaining distance from this point to this? Total distance is a 4.5 meter, right? And this distance is a 4.5 minus A, right? We are consider this distance is A, and here we get the 4.5 minus A distance. Okay, we are consider the, here is a similarity of triangular principle. Similarity of triangle principle. Okay, what is the similarity of the triangle principle? Yes, similarity of the triangle principle. How to calculate? See how much distance we are considered A distance. A divided by how much force is at that C point? 1.4 kilonewton, right? As it is 1.4 kilonewton equal to the next distance 4.5 minus 1. 4.5 minus A is there, divided by what? This force 7.6 kilonewton. 7.6 kilonewton. Okay, if you have calculated this 7, I will calculate 7.6 divided by 1.4. Then see A plus, I will take this A left side, then you will get the plus A equal to what? 4.5. Okay, if you have calculated this, then you will get the A is equal to 0.7 meter. Means we have calculated this value from this C to this zero shear force, where we will get 0.7 meter. Means from the A point, from the A point, this shear force 0 will get at a distance. This total distance is a 2.5 meter A to C. 2.5 plus A is there, means you will get the 2.5 plus 0.7 is there. 7 is there. Okay, you will get the total this 12 and 3.2 meter. Okay, from point A, you will get the 3.2 meter. 3.2 meter. We have calculated the total distance from the A point. Then you have, once you have calculated the distance, here we will get this shear force, where we will get the 0 from A point, 3.2 meter. 3.2 meter, right? Then how to calculate the maximum bending moment at that point? How to calculate this? You have to take the moment about that section. We will consider here section XX. Then what is the maximum bending moment of that point? BM max at the section XX is equal to, check the bending moment. This one 11.4 kilonewton. 11.4 kilonewton. Up to the distance of that shear force XX section 3.2. 3.2 positive. Okay, check that. Positive. 11.4 into 3.2 is there. Okay, this here we will get this. Here up to that we have to take the moment of XX. Okay, there is again one more force is that in the anti-clockwise direction 10 into what remaining distance? This distance we have find out 0.7 meter. 0.7 meter. Okay, minus 10 into 0.7 meter. Again there is a UDL is that. What is the value of that UDL? Minus 2 into what? We have considered this distance only. Don't consider that distance this side. Okay, only this 0.7 is there. Then how to add that? 0.7 divided by 2. Where is that? 0.7 divided by 2. Okay. Then if you have calculated this, all this value, then you will get the maximum bending moment at that section is equal to 29 kilonewton meter. 29 kilonewton meter. Okay. Then you can draw the parabolic curve in this way. Okay, here you will get at this point 29 kilonewton meter value. Okay, now you are getting how to calculate the maximum bending moment, and you get that answer. Yes, you will get the 29 kilonewton meter. Okay, all of you getting how to calculate, how to find out the maximum bending moment. You will get the positive maximum bending moment. Okay guys, you have to visit and watch the channel. If you have any query, then you can comment. I will explain in the next lecture. Today we will stop here.